Hello. Um, there's another video on the syllabus that is like 14, 15 minutes long. The syllabus is huge because the University of Minnesota requires it to include a bunch of information to cover legal bases. All right. So this video will go through and look at the course format and how the textbook is used or the lab book is used. So, physics for inquiry, University of Minnesota, 4 credit physical science with lab class. I click on classwork, and I'm not going to look at the syllabus. Instead, I'm going to look at the book, Electric Circuits. So this is a lab class. You'll notice here that I actually have the book marked down as an assignment. That way, everybody gets their own copy of the book, and that allows us to possibly do some writing into it. If you're using your school Chromebook, we have things lined up so you can use Lumen PDF. It takes a long time to open stuff through Lumen PDF, but it allows us to insert text into the PDF so we can type into it. Connect to Google Drive? Yes. Upgrade for free. I'm just going to click this X to get rid of that because otherwise it takes a long time. I've already used Lumen PDF, so I went through all the other steps that it will ask you to do. So it will ask you to grant Google access. It will ask you a variety of things. Which Google account do you want? Blah, 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 blah. And it just goes on and on and on and on. But eventually you will get to a spot where it will let you open up the PDF. Once we get there, well, here we are. So electric circuits, as I go down to the first page with stuff, as we look at this, you'll note that it's not like a textbook that includes, hey, here's a term, here's a definition. Um, this is where we see it in the real world. This is how we can explain things. Here's an example problem. This course does not have any of that. Instead, this course is a class where we use labs to figure out how things behave. So I'm going to zoom in here and we'll take a look at what we've got. So simple circuits introduce simple electricity or electric concepts that enable us to account for the relative brightness of bulbs we observe. We investigate the conditions when a bulb lights brightly, dimly, or not at all. And experiment 1.1. You hopefully have your lab kit. I'll be dropping some off to those that send me an email. Obtain a battery, a bulb, a wire. That means just that, a battery, a bulb, a wire. No bulb holder, no battery case, just those 3 things. Um, connect these in as many ways as possible. Sketch an arrangement in your notebook. On one side of the page, list arrangements in which the bulb lights. On the other side of the page, list arrangements in which the bulb does not light. So, if you have a lab notebook or if you have a notebook, you can document all of that stuff in your notebook, and you really should, because in the future we'll have questions on quizzes or future sections of this section in the book. Uh, there will be questions that say, "Hey, what proof do you have from observations on how things work?" And if you don't have those things written down, you're relying on your memory to go back a week or two or possibly more to try to answer questions. Having them written down is just so helpful. So with Lumen PDF, we can click on this, and that allows me to, um, uh, I can just type text in wherever this goes. And if it starts to expand, there is a way, I think. See, I click on this little arrow thingy, that gives me a box, and I can kind of adjust how I'm going to fit that stuff in. So that's kind of helpful. And if I don't want that, I can delete it. It is also possible to do this freehand tool. So you can draw on it. Now, that obviously depends on what sort of a device you're using to do this work. If you're using one of the school's Chromebooks, well, most of them aren't touchscreen, so you probably can't really do anything. But if you have your own phone that has a touchscreen, you might be able to draw like a battery and a wire and a bulb. Um, you might be able to draw some stuff that shows how what you're doing. Um, that could end up being helpful as we're going through and doing these things. If you're not able to draw that stuff directly on the screen, or if you don't have a method to do that that's quick and easy, don't go and don't find a way, don't make it a troublesome, challenging. I'm going to spend an hour and a half making the best little diagrams you've seen with these little tools. Well, premium anyway. Don't go that route. Instead, just make sure you're writing these things down pencil paper. That's what we do when we're in class, and that's the how lab notebooks are used. Um, but you should, when you're writing things down in your notebook, you should um, be stating, hey, experiment 1.1, this is my diagram. So in your lab notebook, you should write experiment 1.1 and draw and answer all of those things. That will be really helpful for you. Um, Generally, when we meet in a physical structure, when we're in school face to face in years past, I in those circumstances I never grade or check the lab notebooks. Those are for you to reference to answer future questions and to double check on predictions and things like that. In this case, in this setting, I might just occasionally ask you to include a picture that just shows that you're doing something. If you're typing stuff into this PDF, that'll work. So that's experiment one. You should have multiple sketches, state the requirements, and then we move on to exercise two, and we do that. Experiment three, and I think in the Google Classroom I said don't worry about experiment three or four. Experiment three, exercise four, discuss your definition with a staff member. So when you get to this section, that is when you're going to end up going to do use a Google form to do a checkpoint. So the Google form just has some multiple choice questions and tries to make sure things are working okay. And if you are seeing questions, the same question, like you complete a section and then you go back and you do another section that is almost identical, uh, then that's a sign that maybe some questions, we missed some questions, and the Google form is lined up to try to help us improve our answers on those sections. Once you leave that Google form, once it allows you to go through and hit submit at the end, you should be in a pretty good spot. We should have addressed everything. If you've had to make changes in what you thought to get answers correct on the Google form, make darn sure you document that in your notebook or on this PDF if you're typing. And then we move on to experiment 1.5 and experiment 1.6, and we just keep on going. And you see that these things are all experiment, document this stuff. Hey, and then there's like hey, one student thinks this, one student thinks that. What do you think? Explain your reasoning to a staff member. Whenever there's an explain your reasoning to a staff member, that's a sign that we're going to have a checkpoint and a Google form. And that's going to be most of the way things go day by day by day. Once we finish like all of section one, um, then there will be some supplementary problems that will be asked. So there's section two. The supplementary questions are kind of like end of chapter or end of unit questions that are just designed to double check some things and make sure things are going okay. I hope that makes sense about how that is structured. There you go.